Dr. Sujiya, Assistant Professor in the Department of Computer Application at Dr. S.U.J.S. College of Arts and Science. Today, the series 3 video I'm going to discuss about the deadlock avoidance in operating system. In the previous two series, in the first series, we have discussed about what is a deadlock with a real-time example, and in series 2, we have discussed about the deadlock prevention, where 3 preventive methods have been discussed with 3 approaches. And now we are going to discuss about the deadlock avoidance. So deadlock avoidance is used by the operating system to avoid deadlock in the system, and this process needs to specify the maximum resources needed by the operating system so that the operating systems can stimulate the allocation of available resources to the existing process and check if it is possible to satisfy the need of all process requirement. So what is the difference between a deadlock prevention and deadlock avoidance is? Deadlock prevention is to take measures to prevent deadlock. Here deadlock avoidance is we have to take initial steps to avoid the deadlock that is going to occur. Anyhow it is going to occur, but we have to take initial measures to avoid such deadlock. But how can an operating system can avoid a deadlock? By knowing the maximum resources required and by process initially, and also the operating system should know the free resources available at all time, and the operating system tries to allocate the resources according to the process requirements and check if the allocations can lead to safe state or an unsafe state. If the resource allocations leads to an unsafe state, then the operating systems do not proceed further with the allocation sequence. So, just a recap here, the deadlock is a situation that occurs in an operating system when any process enters a waiting state before another waiting process is holding the demanded resources. And it is a common problem in multiprocessing operating systems where it shares a specific type of mutual exclusion resources, and this is called as a soft mode of software. Here we have two states, one is safe state and another one is unsafe state. So which is called as a safe state is all the processes any order. If a system is able to allocate or satisfy the maximum resources required by the process, it is said to be safe state. And so safe state does not lead to a deadlock. In unsafe state, if the operating system is not able to prevent processes from requesting resources, which can also lead to a deadlock, then the system is said to be an unsafe state. An unsafe state does not necessarily cause deadlock. It may or may not cause a deadlock. Here, how a deadlock avoidance works. Here we have three processes, process P1, process P2, process P3. And the maximum required time for P1 is 9, and the maximum required time of P2 is 5, and P3 is 3. And the current available time for process 1 is 5, and process 2 is 2, and process 3 is 1. So process 1 needs extra 4 to complete a task, and P2 requires 3 more resources to complete a task, and P3 requires 2 more resources to complete a task, but currently it has been available 5, 2 and 1. So in such a case we have to see P3. P3 as only currently available is 3, and 1 is required. If such a case, if P2 completes the process and free ups, P3 can use the resources. If suppose P3 completes the process with allocated resources, then these resources will be freed and that can be given to the process 1. So process 1 needs a maximum of 9 resources to complete its execution. P1 currently allocated 5 resources and needs 4 more to complete this execution. P2 process needs maximum of 5 resources and currently allocated with 3 resources, so it needs 3 more resources to complete its execution. So the operating system knows that only 2 resources out of total available resources are currently free. So in such a case, 2 resources are free from now. Only P3 can satisfy its needs for 2 resources. If P3 takes 2 resources and completes its execution, then P3 can release 3. So totally we will be having 2 plus 1 resources. Now the 3 resources can complete its execution and it can release 5. So 2 plus 3 is freed up. Now 5 resources are free and P1 can now take 4 out of 5 free resources and complete the execution. So with two free resources available initially, all the processes were able to complete their executions, which leads to safer state. In case if does not up to the maximum to complete a task, then it will enter into an unsafe state. So this is what safe state and unsafe state has been explained. Thank you.